So take down the problem. So we'll straight away start with the problem. So we know that, right? So PL is nothing but fixed array and programmable OR array. Okay, so that is the meaning of PLA here. Fixed array na programmable array na. So it is a different one. We have the kinds of PLs. So this programmable array and fixed OR array. Okay, so programmable in the sense, so we can eliminate the usage of these AND gates, and the OR gates are fixed here. So the number of OR gates that are used is fixed here. Okay, so that is the kind of circuit we'll be having. So that is PAL. So programmable array logic. Okay, so programmable array logic. It is a device with a fixed array and a programmable and array here. Okay, so this is the case here. So OR array is fixed and and array is programmable here. Okay, and it's easier compared to this PLA here. Okay, but not as flexible as PLAs here. Okay, so programmable array logics are easier to design, but the flexibility compared to PLA, it's less, because when we are doing the programming, the designer can choose the usage of number of gates. Okay, or reduction in number of gates can be done with the help of this programming part. So if they are fixed, we have to follow that fixed pattern only. So there is no need to change. I mean, we can't change that patterns there. Okay, so in case of the fixed arrays here. Okay, so fixed arrays are easy to implement, but they are not flexible. Okay, they are not flexible here. Okay, so take down the problem here. So programming table will be a little bit different. So we'll check those programming tables here. So those assignment problems, I have to finish it today. And after coming to your college, first of all, I'll check your notes. So where it should contain all the assignments and the class notes. Okay, you should have all those things. Ignore the problem. So tabulate the PL programming table for the following Boolean functions. Okay, for the following Boolean functions. So A of XYZ that is equal to sigma of 1 2 4 6 1 comma 2 comma. Okay, and B of XYZ sigma of 2 3 7. Okay, and C of XYZ equal to sigma of 0 4 2 6. B of XYZ is equal to sigma of 2 6. So this is 0 4 5 6. So draw the two tables. So there is no complement form here. Just I need the values of ABCD. Okay, I need the values of this ABCD here. Okay, and why this much of size? This is X, Y, Z, and this is X. 0, 0, 0, 1, 1, 0, 1, 1, 0, 1. So what is the value of A here? So tell me faster. So 1, 2, 4, 6. So this is 1 and this is 2 and this is 4 and this is 6, right? So this is a pair here and this is another pair. So these two will form another pair. This is the individual term. Okay. The value of A is equal to, what is this value here? What is this value?
YZ bar.
Yeah.
YZ bar.
YZ bar. And this two, this X,
Z
uh,
bar.
XZ bar
XZ bar.
plus this one, X bar, Y bar, Z.
X bar Y bar.
Y bar, Z. So this is A here. And the value of B, and this is X, and this is YZ. 0, 0, 0, 1, so 1, 0, 1, 1, 0, 1. And what are the values here? Sigma of 2, 3, 7. This is 2 and this is 3 and this is 7. Okay, so two pairs. So this 2 and this 2. So B is equal to, so it is YZ plus X
X bar
bar,
Y.
X
X
bar,
bar Y.
X bar Y. Okay, so this is B. Okay, and coming to C here, values of C, and this is X, so YZ 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. Okay, and so what are the values here? So C of XYZ is equal to 0, 4, 5, 6. This is 0 and this is 4 and this is 5 and this is 6. Okay, so pair, this is another pair and this is another pair. Okay, and this is C is equal to, so what is this value here? It is Y bar, Z bar plus these two values X,
X Y bar.
X, Y bar and plus these two values. It is X,
X Z bar.
Z bar. So this is the value of C. Okay, and the value of is X here. So Y is it 0, 1, 0, 0, 0, 1. So 1, 0, 1, 1. Okay, and this is D here. So D is equal to, what is the value here? 2, 6. So where is 2 and where is 6? So this is 2 and this is 6 here. So this is D is equal to YZ bar.
YZ bar.
Okay, so there is no need of complement terms here. There is no need of true forms and the complement forms. So just one need only A, B, C, and D here. So we have a programmable AND array and fixed OR array here. So in case of PALs here. So coming to the diagram. Okay, so diagram we can draw straight away. So we'll follow this method. So earlier method we can follow. So right. So A. Sorry. First of all, we have to draw the programming table. Okay, so PL programming table. So 1 minute. Yeah. So we'll draw the PAL programming table. Okay, so first of all, write the product terms as it is like the previous term. So what is the value of A here? A has the product terms of, write all the product terms. So there is no need of minimizing this. So write the product terms related to A. So A product terms A one time manaku. So YZ bar. So repetitions also you can write. So YZ bar, XZ bar. Okay, and X bar, Y bar, Z. Okay, so there is a first product term here. I mean, first value of A, and next one is YZ and X bar Y. The second one, the third one, so Y bar, Z bar. Let's write all the product terms related to this one. So Y bar, Z bar, and so we have X Y bar, and next we have X Z bar. The last one is YZ bar. Okay, so these are all the product terms here. So I didn't check for repetitions here. So these are the product terms. And next one is and inputs. And inputs. Try to write all the and inputs here. Okay, and inputs. So for the first one, what are the and inputs here? So product terms of XYZ. This is X, the small x or capital X, so whatever. So X, Y, and Z. Okay, so YZ bar don't have X here, but it has Y and Z. So Y is normal form and Z is complement form. And XZ bar, it is 1 dash 0, and X bar Y bar Z is 0 0 1. And coming to this YZ here, it is dash 1 1, and X bar Y is 0 1 dash, and Y bar Z is, sorry, am I audible?
Yes, sir.
Yes, sir.
Please respond now and then, because I'll be presenting the screen. I don't know whether what is the scene going on there. So 1 0 dash, and XZ bar, this is 1
Zero.
0. Okay, and the last one is YZ bar. This dash 1 0. Okay, so this is the and inputs here, and the last one is outputs here. So or outputs are fixed here. Okay, the outputs are will be having 3 outputs. Sorry, 4 outputs. 4 OR gates should be used here. So there is no true forms and the complement forms here. So A B C D. Okay, sorry. The outputs will be having 3 outputs, right? So what is the value of outputs here? So those are A, B, C, D, but these first 3 product terms will constitute the value of A here. Okay, so A is equal to, so what is the output we got here? So YZ bar plus these product terms will give YZ bar plus XZ bar
X bar plus
X bar, Y bar, Z.
X bar, Y bar, Z. Okay, so that is the first term here. First three product terms will give the output of A here. Okay, and next two product terms will give the output of B. So B is equal to, so YZ plus X bar Y. Okay, and the third product term, so C will give the third Y bar Z bar. So it is Y bar Z bar plus X Y bar plus XZ bar. Okay, that is the third one. And the fourth one, D is equal to
YZ bar.
YZ bar. Yeah. Okay, so this is a product table here. So PL programming table. It's quite simple. Just what we got in the K maps is presented here. Okay, so what we got in K map is presented here. Okay, so we need 4 OR gates. The 4 OR gates has these inputs and AND gates. So what is the maximum number of AND gates used here? So here we have to use 3 AND gates, 3 product terms gavatti. 2 AND gates, 2 product terms. We have 3 AND gates. So maximum of 3 AND gates here. So what we'll do here is, so we'll use 3 AND gates for each and every product term here. Product term. Okay, so A will be used 3 AND gates here. So B will be using 3 AND gates. But whatever the unused AND gates will be put as a cross mark there. Okay, so if I use AND gate here and if I put as a cross mark here, I will say that there is no, I mean, we are not using that AND gate here. Okay, when you want to get a defined structure, so what we are going to do here is, so we will draw the table like this. We'll draw the circuit diagram like this. Okay, so wait, the method, I'll show you the method. How to draw the diagram. So first of all, the similar way. Okay, so similar way like A bar, sorry, X Y X bar, Y bar, Z bar. Okay, we'll follow the similar way there. Okay, so diagram will be like this. So you are clear with this the programming table, right?
Yes,
okay,
sir.
you are clear with this programming table. So now we will draw the diagram now. So diagram will be like this. So we'll follow the same method. So there is X. And we have Y, we have Z, this is XX bar, and Y bar, Z bar. Okay, the things are same here. So what we need, So actually, what I told you here is we'll be using a maximum of 3 AND gates for each product term. So 4 product terms are there here. So 4 product terms should consist of 3 AND gates. So the structure will be driven like this. So me structure draw చేయాలంటే, so you draw this structure like this. So 1, 2, 3 AND gates for each product term. So this one, and this one. Okay, and this is given to an OR gate. So this will be A. Okay, so this is A. So A consists of YZ bar. So what is YZ bar? This is Y. Where is Y here? So this is Y, and this is Z bar. So YZ bar. Okay, and what is the next one? So X is Z bar. This is X here, and this is Z bar. And the third product term is X bar, Y bar, Z bar. So X bar, Y bar, Z. This is X bar, this is Y bar, and this is Z. So this is A. Okay, so coming to B here. So B also I'll write it as 3 AND gates only. Okay, so I'll write 3 AND gates only, but I'll not give the connections to that. 1, 2, 3 AND gates. Okay, so 3 AND gates are given to an OR gate. Okay, but we have only connections for only 2 AND gates. So third AND gate is not used. I'll put a cross mark. What we had to do here is cross mark in center. Okay, so I mean this is not used here. So only we'll be using YZ here. So this is Y, and this is Z. Okay, and the next one is X bar Y. So where is X bar Y? This is X bar, and this is Y. Where is Y? Yeah, this is Y. So we'll not use any this AND gate. So this is, I mean, this is made as cross mark here. Okay. The third one. So what is the third one? It is we have 3 product terms. So, okay. 3 AND gates. So 3 AND gates are given to an OR gate. Okay, so this is B here, this is C. So this will be using all the product terms here. So Y bar, Z bar. So where is Y bar, Z bar? So this is Y bar, and this is Z bar. X Y bar. So this is X here, and this is Y bar. And we have XZ bar. So this is X here, and we have Z bar. This is Z bar. So all the 3 OR gates are used here. Clear?
Yes, sir.
Okay. Fourth one, so with the 3 OR gates only. So fourth one ఏం చేస్తారంటే 3 AND gates డ్రా చేయండి, బట్ 2 AND gates యూజ్ చేయం దాంట్లో. ఓకే, సో వెయిట్, సో 1 AND gate, so 2, wait a minute. Okay, 1 AND gate, second AND gate, third AND gate. So we will not use second and third AND gate, so put it as a cross mark there. So we'll be using only 1 AND gate, so that is equal to Y bar Z. Okay, so Y Z bar. So this is Y here, and this is Z bar here. Okay, but all the 3 this are given to an OR gate here, so that will be equal to B. Okay, so this is A, this is B, this is C, and this is D. So B we don't use 1 AND gate here, and D we don't use 2 AND gates. Okay, so like this. So we don't use two AND gates. So this AND gate, second AND gate, third AND gate are not used here. So put it as a cross mark there. Okay, so the structure will be like this. Clear?
Yes, sir.
Okay, so this is how we'll go with the PL level. So most of the things it is similar, but the small change is like uh, we'll not use this. Will not use true forms and the complement forms. Okay.
Yes, sir.
Okay. So wait. So you can draw the diagrams in various ways. So this is one of the way here. So we can find other ways also. So major thing is similar. Wait. Wait a minute. So take on this problem. Yeah. Take on this problem. The same case. Done?
Yes, sir.
Okay, and so that is a problem we have to do. And yeah, so this is a problem we discussed right now. Right? Yeah. So problem we can write like this also, like so x bar, y bar. So but I have taken in the upside, so not a problem because PLs ki rundu ఇది చేయొచ్చు కాబట్టి. So follow the earlier method only, or else you can follow this method also. Okay. So you can check the last one here. So we are putting a cross marks here. Okay. So for D we are putting a cross marks for because there are no product terms here. The structure will be like this. So for a PL one here. Clear?
Yes, sir.
Yes, sir.
Okay, so this is about, I mean, you can follow this structure or the structure we discussed in the last PLAs. PLAs ఏదైతే structure follow ఏమో అట్లే చేయొచ్చు, but we'll be having some change here. Okay, or else you can follow like this also, because you know everything is like, if you want a neat representation, you can follow different methods. Okay, yeah, so take down the last problem. So the problem I have given right now is assignment for you, or the earlier problem. So take down the last one. Derive PLA and PAL programming tables for a combinational circuit that squares a 3-bit number. Okay, so input is 3-bit number. For example, if I say that inputs is ABC, so outputs are like a square of the input number. So we'll get up to 9 square. So 9 square means 81. So 81 means we can use up to 2 power 6. What is 2 power 6? 2 power 5 is 32. 2 power 6 is 64. Yes, S0 to S5 can be used here. Okay, the squares of the numbers. So what I have to do here is, so find the equations for S0 to S5 ante, so we'll get it for so 5 equations. So we need to draw it for 5 equations. Okay, so where S0 S1 మీరు 4-bit స్క్వేర్ లో చేసింటారు కదా, సో అక్కడే వచ్చేస్తుంది ఒకటి. S2 అనేది S1 అనేది 0 వచ్చేస్తుంది. సో there is no need of mentioning that, and S0 is C వస్తుంది. Okay, S0 value is C, so there is no need of those 2 values, so we can go for the 4 K-map values. So what we need here is, so we need a programming tables only, so no need of diagram here. Okay, there is no need of the diagram. So when we draw the truth table, so if inputs are ABC, outputs are S0 to S5, so S1 will be 0 here and S0 will be C. Okay, S0 will be equal to C. Okay, so there is no need of mentioning those S0 and S1 in truth tables here. So we have to find the K-maps for S2, S3, S4 and S5. So whereas PLAs need both true forms and the complement forms, and PALs need only the true forms only. So there is no need going for the complement forms. Okay. Clear?
Yes, sir.
Yes, sir.
Yeah. So this is the thing here. So this is your syllabus. We are left with only this topic. So memory decoding topic. So that memory decoding, we'll see that. Okay. So we'll see that the concept of memory decoding after finishing this, the previous concepts. Okay. So meanwhile, the PLA problems, so 4 problems ichanu, like 4 K-maps, as I mean 4 variable K-maps thing. So that is also that is also important for you. Okay, and I think we covered almost all topics. Sequential programmable devices. Yeah. Okay, so only memory decoding is left. So whatever circuits we discussed is about the combination circuits only, BCD, XS3 converters or whatever the converters. So we discussed about those circuits only. Okay, so we are done with this unit here. So only with one topic. So one topic is like we'll discuss later. Okay, so that is a simple concept only, but you have to understand this concept here. Okay, so the major unit starts here, the flip-flops. Okay, so don't miss these classes. So the flip-flops, the concept of flip-flops, it's, you know, if you understand, if you listen only, you'll understand, or else you'll not understand this here. Okay, so this is the first part here. So next we'll see the analysis part, and next we'll go for the resistors part. I need hardly 20 to 30 classes for this unit. Okay, so hardly like మేబీ సో కొంచెం ఎక్కువ ఎగ్జాంపుల్స్ చెప్తే ఈజీగా 20 to 30 కావాలి. I'll see. So whether based on the timing, so I'll maximum complete that within 20 hours. Okay, and this unit, so I think this is not required. So this unit is only this concepts. So hardly 4 to 5 classes for this. Okay, we will see by the end of this month. So we'll complete that. Okay, or else I'll be taking classes, 2 classes daily, and try to finish it within 15 days. Okay, so 15 days is my target for completing this syllabus. So meanwhile, you go to the recordings. Okay, so you go to the recordings, and so next class we'll start this sequential circuits. Okay, so with latches, introduction to latches, flip flops, and all those things. So please be attentive in the classes. These concepts are very important. The sequential circuits, the concepts are very important. What I why mean to say here is, I mean, if you understand, if you listen only, you'll understand these concepts here. Okay, so I have to listen definitely. Okay, so that's all for today. Yeah, I can drop your attendance and you can leave. So thank you. I'll be sending the recordings today itself.
Okay, sir.